Hello, welcome to the fourth lecture on nonlinear modeling. Today we are going to talk about contact. Previously, we've introduced contact as a type of nonlinear problems because the contact radius and the contact force are both nonlinear functions of displacement. So this is the case with the ball contacting with a soft medium. Today we are going to take a more in-depth analysis for this problem, for contact problem in general, and we'll start with the weak form. Then we'll talk about the normal and tangential constraints and how these constraints would affect our solution weak form. And then we'll specifically mention two major methods to solve contact problems. They are namely the penalty method and Lagrange multiplier method. Then we will give a truss example to demonstrate these two methods. And last, we'll talk about some practical issues in modeling contact problems with the finite element method. Now, let's take a closer look at the surface of contact between two bodies. We have body 1 the contactor and body 2 being the target. So let's just imagine that they are actually in contact, but for clarity, I separated the two bodies so that we can see the forces, attractions acting on the respective contacting surfaces. So in fact, gamma 1 and gamma 2c, they are coinciding with each other, so they are in contact. They should be, we can call them both as gamma c. And tau C1C is the pressure applied on the top surface, and T2C is the pressure applied on the bottom surface. So for equilibrium, they needs to be same in amplitude and opposite in directions. And let's denote Tc to represent T1c, and then T2c would naturally be minus Tc. The weak form for the current configuration is this one when we don't have a contact problem. So on the left, we have the water work done by the Cauchy stress within the body. This is the internal water work. On the right, we have the external water work done by the body force, and applied traction P represents prescribed. In the case of contact, we have multiple bodies, so we need to split these integrals into multiple parts. So let's say we have n body. Here n would be equal to 2. And in addition to this, we have the contribution of the contact tractions to the water work. So they would constitute part of the external water work, because these contact tractions, they are applied on the surface of the body 1 and body 2. We also need to sum up all the contributions from the contact pressure. And in this particular problem, this part is composed of two parts. So we have two bodies. This first part, this is a contribution from the second part, and T1c, we can write it as Tc. T2c, we can write it as minus Tc. And we can replace gamma 1c and gamma 2c by gamma c. Then we arrive at this expression. So we have the delta U1 minus delta U2, which is the difference between the variations of U1 and U2. U1 means the displacement field for body 1, and U2 means that for body 2. So note that gamma c, which is the area of a surface of contact, is a nonlinear function of our displacement U. As mentioned earlier with the example of ball contacting with soft medium, the radius of contact is a nonlinear function of the displacement, and here, similarly, the area of contact is a nonlinear function of our displacement solution U. And in practice, in FEM, we need to search for this gamma c in every iteration based on the current value of our displacement solution. So this is extremely complex, but it's doable. So this is nonlinear function of displacement. And secondly, we have an unknown pressure or traction, Tc. So we know that when the two bodies come into contact, this surface would coincide with this surface, and there will be equal and opposite tractions applied on these surfaces. but we don't know the amplitude of the two. So based on this equation, we cannot tell exactly the amplitude of TC. And there are two ways to solve for this problem. So now we have a problem with two unknowns. One is U, the other is TC. So this is also unknown, but we can establish a relationship between gamma C with U. Based on the current displacement field of body 1 and body 2, we can find, okay, now this part, they are coming into contact. So this is, although complex, but it's possible. So now we have two unknowns with one equation. There are two possible ways to solve this problem. One is to relate this unknown TC with U. Then we reduce to a single unknown problem. The other is to augment our system equation by one more equation, so that now we have two equations for two unknowns. So the first method is the penalty method, and the second method is the Lagrange multiplier method. We'll talk more later.